Okay, simple task. So you would think it's very simple. We got 2 meters here. They both have auto hold features. So I'm gonna put this on auto hold, and we're gonna put this on auto hold. This is not my precision voltage reference. This is a cheap one, but for being a cheap one, it's fairly accurate actually. Probe masters are the Fluke, and Brymans are the 121 GW. So we'll take the 121 GW, get a reading, and then pull it off. Alright, that's how it worked. Do the same thing over here. Good. 24995, 24989. Okay. Now, I'm actually going to turn the auto hold off on that one because I don't think that one was a good reading. Now it's not going to give me a reading? Really? Just because I flipped the auto hold off and then turned it back on? This is the problems I've been having with the auto hold feature. Oh, yeah, and then I removed the probes and look what happens. I get a reading. What the heck's up with that? Alright, now I figured out it needs to be more than 40 millivolts difference for the auto hold to actually recalculate and display a different number. It's going to say that should be more than 40 millivolts different. And that's the problem with the auto hold. I removed one probe. You saw I didn't drag it off. I just removed the probe and it automatically gave me a different number. You gotta do that super quick or something. Now, 24996. This could be 1 microvolt off, and it will detect the change. See? It just changed to 5. So this is what I expect from an actual auto hold feature with a meter of this type of resolution. Even 1 microvolt, it should calculate. There it goes. It just changed to the 6, which is the drift and that I expect from this particular voltage reference. So that I expect. This I figured out with my power supply, 40 millivolts. You need to be at least 40 millivolts difference, or you're not going to get any difference at all. Or you could just hope that that happens every time you go to pull your probe off. How are you supposed to work auto hold if it won't? Okay. I don't know if this really helps. If it doesn't help, I actually have no clue. I'm gonna do it anyway. Okay, we got an actual reading. Now, is it a true reading? I don't know. Let's turn it off. Because sometimes auto holds aren't actually truly what it sees. Actually, that was pretty good. It was only about 2-3 microvolts off. Flipping 2 and 3 microvolts off. So that's actually not bad at all. But then I can say the same thing for my Fluke. I can ask that same question. Is that a true auto hold? Well, the only way to do that is just turn it off and actually find out. So I'm flipping 6 and 7. So that's actually a true auto hold. So I seem to have a better auto hold here than I do on the 121 GW. The 121 GW, of course, we are talking twice the amount of cost here for this, for the Fluke versus this. So there's a big difference there. Now you can see the bar reacts quite well, Oh, I'm not on auto hold, sorry. So let's reset this back over and go to auto hold. Now I can't get my rating on auto hold. I wonder how long I needed to leave it sit here before I finally get a rating. You know what? Let's just reverse the probes. Hey, look, that was a big enough difference to actually see a change in the numbers. There we go. And as soon as I pull them out, okay, it stayed. Now let's move on to oh, I had this on normal hold, that's right. So let's move on to the next number, 5-volt range. Not bad. I'm afraid to, take the auto hold off to see what the true number is. Let's just assume the true number is 20, a little higher than what we're actually seeing. 7.5-volt range. And so far I've been able to pull these off without getting that little bumping around numbers. I've been getting lucky. Got lucky again. Okay, so not too bad. Just out of curiosity, that 10.002, what is the actual number on that? That was the actual number, okay. Let's go back and look at them again. I think I said 1.8. I said to make an assumption of 2.0. I was actually a little off on that range of changes. That one is dead on, as with this one. The only thing that really annoys me about that auto hold is, well, you saw how it changed when I tried to use it and pull my probes off like that. That really annoys me, and it doesn't just happen in the voltage range. It happens in, well, any range that I try to use auto hold actually. It can happen in if I'm going through a bunch of resistors and I just want to test a whole set of resistors, and I'm just boop, 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 and I look over, but I realize that it's actually wrong because I pulled the probe off of it and it changed as I pulled the probe off. I thought it was the resistance changing as I was sliding the probe off of the resistor leads, but then when I noticed it also happened in the voltage range as well, then it became officially an annoying bug in the firmware to me. That's the way I see it. The other thing is, if you want to auto something out, now this gets a little, I don't want to call it complicated. It's not really complicated. It's just you have to do it a certain way, especially when it comes to the voltage. Take for example, for some reason I want a negative 2.5 here. So what I really actually need to do is I need to go into auto hold, and then I need to zero it out. But am I really in auto hold anymore? No, I'm not. Now I'm just taking live readings. So I've lost my auto hold. Okay, well maybe that's not the way I was supposed to do it. Maybe I'm supposed to zero it out first and then use auto hold. No, because then I get the real rating. So you cannot relative anything out and use auto hold. Auto hold will always give you the true reading. There is no way to get, and there it goes changing again just by pulling the probe out. Hopefully that's more than 40 millivolts. There it goes. I kind of expected the same kind of performance out of this. If this has 1 microvolt off, it will actually change that 1 microvolt. So as I'm watching something and let's say the device under test is warming up and is changing 1 microvolt at a time, I can actually see that, reflect it, and it will beep every time it gets to a different number. But not in the case of this meter. It has to be at least 40 microvolts difference between the number that it last auto held to the new number for it to actually register, calculate, and display the new number. So if you think that it may be slightly off for whatever reason, you have to just shut your auto hold off and just forget about everything that you were doing there. So I'm going to go to 7.5 here. Okay. I'm at 7.5 volts. And it wasn't reading for some reason. Alright, what's going on here? Now, how did I fix this last time? 5 volts. And that's the bug. That's me disconnecting the probe. Oh yeah, I took it to a negative voltage. That was enough of a change that it actually went negative. And then when I put it back to a positive, I switched my probes around. I'm not getting the reading I'm expecting. Let's go to 10 volts. Did I lose my auto ranging? Is that what happened here? Yep, it's pulling up over limit. I don't know what happened to my auto range, but I lost it somehow. So here I would expect 7500. Okay, and I would expect this to be O2. This I would expect to be all 9s, and it's not quite. So I'm guessing if I turn this off, oh actually, that's right. If I look at this on the oscilloscope, it has an overshoot when I change the modes. So it's actually picking up high because I'm changing. Except for 7.5 and 10. But when I change this direction, it overshoots and then settles down. So that's a good question. We're looking for 24994 as the real number. That was actually 2 off. That's perfect. That's perfect. And I think it might have picked that up a little too soon. Yep, it did. This meter over here with the same functionality, same resolution, if it was to overshoot and do that same behavior, it would reflect that, because even if it changes a microvolt, it does show it. So when I go from 10 down to 2.5 again, it'll show high and then come down. Oh no, it didn't. It actually just picked it up accurately. It's able to read it faster, take more samples, and determine the true voltage, and actually ignore that overshoot, and actually do the auto hold and display the accurate number. What bugs me the most, though, like I said, is this auto hold bug. This whole, reading a number and then pulling it off, and then reading a number and then pulling it off, and every time I pulled it off, the way it would change. That thing here, when you pull the probe off, and like I said, it's intermittent. That's just annoying. That basically makes auto hold worthless to me, honestly. So again, this is a firmware meter. You can update the firmware on it. You can update the firmware on this too, and I had the cable, but I've never had the need to because I've never found a bug in it. But you can update the firmware on this, and well, hopefully I'll report this bug, and I hope there's a firmware fix for that. I think auto hold needs an overhaul. I think auto hold should be able to work with the relativity mode to be able to properly zero it out. I should be able to zero out my probes and still use the auto hold feature in reading ohms. In millivolts, of course, we're going to pick up a little bit of interference. I should be able to at least zero that out to a number that I, using the relative mode again to where I know it is, and then actually still use auto hold as well. They just don't seem to work together. If you enable one, one disables the other, vice versa, but they'll still both be displayed on the LCD. So it's very confusing. You don't know if it's picking up an auto hold or if it's picking up a live reading. Is it doing the math? Is it doing the relative and deducting the relative value from what it's actually reading, or is it not doing the math? So basically you end up turning this off, and you turn off auto hold, and then you get your true number, and at this point you're just like, screw it, why even bother trying to use auto hold? It seems more of a hassle than it's worth, especially when you go to remove from the device that's under test, and you go to remove your probes, and it changes. It just magically changes, and you wonder to yourself, did the power supply on that just die? Did something just happen? Did the 10 mega ohm resistance from multimeter cost too much of a resistance to actually cause a part in line to fail from where I was testing on my device under test? And then you go back to it and it gives you the proper voltage, and you remove your probe and boop, it changes again. And you're like, oh, okay, turn off auto hold. Not worth it. Really not worth it. So I hope you understand the bug. I hope this points it out. I don't know. Is this just my meter? If it's just my meter, please let me know. If it's your meter too, please let EEV blog know, and Dave know, and whoever, and Dave Jr., Dave 2. Hopefully they can fix this. This is firmware version, I know it's going to be asked, 115. And why is it 115? Well, because this is a brand new meter. You see I still have the display on it. So I haven't even changed anything. The only thing I've gone in here and changed is the date and time. That's it. Date and time, and I changed it to Fahrenheit for temperature. That's the only things I've changed on it. I haven't even hooked it up to the phone remotely yet. I haven't even tried any logging. I haven't gotten that far. Auto hold was like the first bug that I automatically noticed, and I wasn't doing it with this one. I was actually doing it with my HP 43301A and my precision voltage reference that I built. And then I was playing around with the power supply at the same time, and my bench meter, the HP, does have auto hold as well, and it doesn't matter if it's a microvolt, a nanovolt change. It will follow that change, and when I pull the probes away, it stays the same number. Just like this will change every millivolt if it detects a millivolt change. This requires at least 40 millivolts. I may be wrong on this number. I didn't exactly go from 35. I was doing it in 5 millivolt increments. So I went to 35, it didn't change. I went to 40, it changed. I did that 3 times, and both times it changed. So somewhere between 35 and 40 millivolts, it requires at least 35 to 40 millivolt change before it actually will re-register. Even though it's sampling it and reading it probably every 3 seconds, it won't bother displaying it unless it's more than 35 to 40 millivolts, which baffles me, because what's the point of a meter at this level of resolution if you're not going to show every bit of the resolution and every time it reads the sample if it notices a change? Why not show that? Probably, again, back to firmware. I'm guessing. I don't know. Who knows? Alright, that's my opinion, and this isn't my official review. Once again, this is just the start of my review. This is just one of the tests I started to run today, and the first bug I ever came across myself personally, and it won't surprise me if I find more bugs going forward, even though everybody thinks that the firmware is pretty much hammered out right now. I have my doubts, but we'll see.